The search for a successor to the Boeing B-52 was a long, costly, and at times painful journey for the US Air Force. In the early 1970s, the Rockwell B-1A seemed to be the answer, but it was cancelled by President Carter on cost grounds and a genuine desire to at least slow down the arms race. With President Reagan installed in the Oval Office, that desire was lessened to a degree, and money for such large strategic projects was easier to come by. The B-1 was resurrected. Not long after it entered service as the tip of the Pentagon's airborne nuclear spear, the B-1 suddenly found itself without a mission. As the Soviet Union disintegrated almost overnight, the need for a nuclear penetration bomber evaporated. As it stood, the B-1B could offer very little in the way of conventional capability, but a rolling upgrade program through the 1990s rectified that, combining new technology weapons with the B-1's existing load-carrying performance and sophisticated weapons system. The result is that today the B-1B is arguably the US Air Force's most important attack platform, and one that is now highly suited to the modern style of warfare. An ability to loiter for hours at a time and to precisely deliver weapons where they are needed with little notice makes it ideal for providing the kind of air cover required by troops in conflicts such as those fought in Afghanistan and Iraq. Rapid retargeting in flight is a key to this vital mission. Such was its success in those campaigns that a move to draw down the fleet in the early 2000s was halted, and development of the B-1B and its systems continues. The B-1 is certainly a large aircraft, but with its wings back it has a purposeful, dart-like appearance. However, with the wings forward, the effect is of an ungainly, rather spindly craft. To provide enough ground clearance for the engines on rotation, the fuselage stands very high off the ground. The B-1 is slightly smaller than its contemporaries and is around 4/5 the size of the Russian Blackjack, which shares the B-1's basic configuration. In weight terms, the B-1 is slightly lighter than the B-52 and again is about 4/5 the weight of the Blackjack. However, in terms of low-level speed, the B-1 is easily the fastest of the big bombers, its performance approaching that of much smaller low-level specialists like the F-111. Thanks to early modifications to the flight control system, the B-1 now exhibits excellent range and endurance figures. To underline its performance, the B-1B holds a large number of world records in its class, including time-to-height records and closed-circuit speed records with payload. The aircraft also set a round-the-world speed record in 1995 during a flight that included 3 practice bombing runs and several refuelings. Although it is obviously still a heavy bomber, the B-1B is surprisingly nimble. Its maneuverability comes to the fore at low level, allowing it to thread through narrow valleys at high speed. Its agility is also appreciated at air shows where steep banks and barrel rolls are performed. For the pilot coming from the B-52, the B-1 is a huge step up in terms of agility, a fact underlined by the cockpit having stick controls rather than the bomber's traditional yoke. It is stable on the approach, and a commendably low landing speed allows it to use relatively short runways. Most flying, however, is performed with the autopilot engaged, which has a number of modes. Low flying is normally performed with the autopilot slave to the terrain-following radar, although manual override is available with the squeeze of a trigger on the stick. A useful feature is the ability to use the radar to generate an autonomous landing system. The radar is used to designate a desired landing point, and the desired glide slope and localizer bearing information is keyed in. The system then sets up the aircraft for an automatic approach, supplying commands to the autopilot and autothrottle, just as it would with a conventional instrument landing system. The B-1 was initially designed to carry its weapons internally. There are 3 bays, 2 forward of the main wheel well and 1 aft. The bays were initially sized to carry the AGM-86A cruise missile, but when the B-1A was cancelled, the cruise missile was reworked as the longer AGM-86B. When the B-1 was resurrected, the AGM-86B was seen as a key weapon, and an alternative bay arrangement had to be devised to accommodate it. The forward 2 bays have a movable bulkhead and are fitted with 3 sets of doors. When carrying cruise missiles, the short forward door is used, covering an auxiliary fuel tank. The 2 aft door sections are opened together to allow the carriage of up to 8 AGM-86Bs on a rotary launcher known as the CRM. B-1Bs were also originally destined to carry the stealthy AGM-129 advanced cruise missile, although only 4 could be carried on the CRM. To boost the total to 16, 6 external launchers could be fitted, each capable of mounting 2 AGM-129s. Both AGM-86B and AGM-129 were tested on the B-1B, but cruise missiles were not adopted, and only 2 aircraft tested the long weapon bay, and only 1 had the external pylons fitted. For its nuclear role, the B-1 had 4 main weapons. Each of the 3 bays could mount a multi-purpose launcher or MPL. Each MPL could carry 4 B-28 freefall bombs, as seen here dropped by a B-1A. The main service weapons were the B-61, with a variety of yield options from a small tactical blast to a sub-strategic option, and the more powerful B-83. Both were laid-arm weapons with delayed fuse options. Theoretically, further freefall bombs could be carried externally, but this was never put into practice. An alternative to freefall bombs was the AGM-69 short-range attack missile, principally a defense suppression weapon with a low-yield warhead. Up to 8 could be carried in each bay on a dedicated launcher. For many years, the only conventional weapons available to the B-1B were the Mark 82 500-pound freefall general-purpose bomb and its Mark 62 naval mine counterpart. The Mark 82 was carried on a preloaded clip assembly known as the conventional bomb module. The CBM had 2 sections, each with 3 diagonal rows of 5, 6 and 3 bombs. With a CBM in each bay, the B-1B could therefore carry 84 Mark 82s. With the Block C CMUP upgrade, the B-1B introduced a new means of carriage. Around half of the so-called 28-carry CBMs were modified to a new 10-carry standard. As the name implied, they could each carry 10 weapons, but of much larger size. The first new weapon to be integrated was the Tactical Munitions Dispenser in either CBU 87, 89 or 97 forms. Up to 30 can be carried. they have been superseded by the CPU 103, 104 and 105 that are versions of the same weapon with the wind correction kit. Block D B-1Bs gained another form of carriage in the shape of a conventional rotary launcher. Each CRL can carry 8 weapons and has a 1760 interface to allow individual weapon targeting. The CRL allows the carriage of 24 Mark 84 2,000-pounders and, more importantly, the GBU-31 2,000-pound JDAM GPS-guided bomb. This is available with a standard Mark 84 warhead or with a BLU-109 hard target penetration warhead. The first guided drop of a JDAM from a B-1B was undertaken in February 1998, and it has since become the aircraft's primary weapon. The B-1 can also carry the smaller GBU-38 500-pound JDAM. The CRL and 1760 interface has also allowed the B-1B to adopt the AGM-154 JSOW standoff glide weapon, of which 12 can be carried, and up to 24 AGM-158 JASSM missiles. In the near future, the B-1 will also carry the GBU-39 small diameter bomb. The B-1B's mission avionics comprises 2 primary systems, the Offensive Avionics System, or OAS, and the Defensive Avionics System, or DAS. At the heart of the OAS is the Northrop Grumman APQ-164 offensive radar system. This multi-mode radar has an electronically scanned phased array antenna and was developed from the F-16's APG-66. Among the modes are real beam ground mapping out to 45 degrees either side of the nose, a high-resolution patch map capability for accurate targeting, velocity update for accurate ground speed measurement, precision position update for offset positional information, high-altitude calibration for accurate height checks, rendezvous mode for finding and tracking other aircraft such as a tanker, and weather detection. The system also provides a comprehensive terrain following and avoidance service. The OAS also draws on inertial and TACAN navigation information. Although the B-1B now routinely uses precision-guided weapons, its OAS can nevertheless deliver dumb weapons with great accuracy. From 2009, the B-1B will be operated with the Sniper XR targeting pod for autonomous delivery of laser-guided bombs. The first test flight took place in February 2007. From the outset, the B-1B was designed with a highly sophisticated defense system known as the ALQ-161. The DAS was designed to detect enemy electronic emissions, compare them to an onboard threat library, and then dispense countermeasures accordingly, either in the form of chaff or flares or high-powered jamming. Antennas for the system are distributed around the airframe, with concentrations in the rear fuselage and at the tip of the fin. The tail-fairing bullet houses the main antennas for the tail warning function. Expendable countermeasures are located in 8 dispensers in the top of the fuselage above the forward bomb bay. During the B-1's development, the DAS proved a nightmare. While it worked adequately against older Soviet radars, it was found to be ineffective against newer systems. It also affected the OAS, and the B-1 came to be known as the self-jamming bomber. Numerous modifications have been applied, and the DAS now works quite well, although not to the full capability that was originally specified. Recently, a towed radar decoy system was added, the decoys deploying from a fairing scabbed onto the side of the tail cone. A comprehensive DAS update was recently scrapped on cost grounds. The B-1 is flown by a crew of 4, consisting of 2 pilots, an offensive systems operator and a defensive systems officer. The OSO and DSO sit a few feet behind the pilots, with a short central tunnel linking the positions. Access is made via a ladder that drops down from a hatch in the flight deck floor. In the original B-1A design, the crew were housed in an escape capsule that ejected as a single piece. When the process was initiated, seat restraints tightened and the main rocket fired to blast the capsule free from the aircraft. Fins nicknamed elephant's ears were deployed to stabilize the capsule before 3 large chutes were deployed. As the capsule decelerated, large bags inflated underneath to cushion the blow. Flotation bags were provided for a water landing. The capsule was extensively tested on rocket sled tracks and also by being dropped from a modified B-52. However, when it came to be used for the only time, when B-1A No. 2 crashed in 1984, the capsule failed to stabilize in the correct position, and one of the pilots was killed in the resultant nose-down landing. The 4th B-1A and all B-1Bs returned to a more traditional escape arrangement of ACES-2 ejection seats firing upwards through hatches. There are fixed seats for extra crew members or instructors who wear parachutes and can bail out through the entry hatch. Although by today's standards the B-1A's flight deck seems dated, when it first appeared, it was considered the last word in large aircraft cockpit design. The rear crew stations hinted at the aircraft's sophisticated systems. The B-1B inherited the basic flight deck layout from its predecessor, albeit with some updated instruments. In the back of the flight deck, the DSO sits on the port side, operating the aircraft's extensive defenses and communications. Opposite is the OSO station, with controls for the radar and navigation suite. DSOs and OSOs are usually cross-trained to perform either task. In the front, the pilots are confronted by a well-laid-out instrument panel arranged in 7 principal sections. Above and between the pilots is an overhead panel with controls for various aircraft systems such as environmental control, refueling, and the auxiliary power unit. Additional aircraft system controls are located in the consoles to the sides of the pilots, that on the left mounting the aircraft commander's throttle quadrant. Between the pilots is a large central console which mounts the co-pilot's throttles and includes a data entry keyboard and screen. The main instrument panel is divided into 3 main sections. Both pilots have a panel on which key flight and targeting data is presented. At the center is a multifunction display that can be used to provide various information such as route data, terrain following radar returns, and the like. Either side are tape-style instruments for key flight data such as airspeed and altitude. Below is a vertical situation indicator with instrument landing system needles. The co-pilot has controls for the weapons bays and undercarriage. In the center of the main panel is a section with key aircraft system instruments. At the top left are backup flight instruments for the aircraft commander, including an attitude display. To the right of this are the primary engine gauges, which use tape-style readouts. Below them is the main fuel control panel. controls for the terrain following and avoidance radar modes, and a display showing aircraft configuration status with wing sweep, slat and flap deployment. Below that is the principal warning display panel. Almost unique for an aircraft of its size, the B-1 is equipped with a fighter-style stick control, indicative of the bomber's outstanding performance and agility. Powering the B-1 are four General Electric F-101 engines. The F-101 was something of a milestone power plant, later forming the basis of the F-110 for the F-16 and F-118 for the B-2. Its afterburning turbofan configuration gave it excellent economy in the cruise, but with an afterburning thrust of over 30,000 pounds. The Dash 100 engine of the B-1A was replaced in the B-1B by the Dash 102. General Electric used the intervening period to make great strides in reliability and engine monitoring technology. The engines are mounted in pairs under the rear section of the inner wing. They are easily accessible for maintenance and removal. The intakes of the Mach 1.25 B-1B are fixed, as opposed to the complex variable inlets of the Mach 2 Plus B-1A. They incorporate radar baffles to enhance stealthiness. Fuel is held in four main fuselage tanks that stretch from the aft of the cockpit compartment to the front of the defensive avionics compartment in the tail. Additional fuel is carried inside the wing carry-through box and in the outer wing panels. Each of the three weapons bays can carry a cylindrical auxiliary tank. A refueling receptacle is located forward of the windscreen, with prominent guide marks to aid the boom operator. The door of the receptacle forms a slipway for the boom when it's opened. The undercarriage is stronger than that fitted to the B-1A, and its 8-wheel bogies give it a much lower footprint than the B-1A or B-52, allowing the B-1B to operate from more primitive airfields. The bogies turn through 90 degrees during retraction to lie flat in the lower fuselage. The variable geometry wing is driven by irreversible screw jacks across a sweep range of 15 to 67.5 degrees. The wings are linked by a torque shaft so that they move in unison. Wing sweep is controlled from the cockpit and is limited to a movement of 1 degree per second to allow the fuel management system to keep up with the change in the center of gravity. A series of stops and interlocks prevents inadvertent flap operation. Yaw control is provided by the two upper sections of rudder, which can travel up to 25 degrees either side. The lower rudder section is used by the gust alleviation system. The all-moving tailerons provide pitch control, moving between 10 degrees nose down to 25 degrees nose up. Roll control is provided by the differential movement of the tailerons, moving through plus and minus 20 degrees. The tailerons are augmented by 4 sections of spoiler above each wing. The spoilers can operate together in the air as speed brakes and as lift dumpers to reduce the aircraft's landing run. For extra lift at low speed, the B-1 has 6 sections of area-increasing Fowler flaps on each trailing edge. They can be operated with the wing sweep at 20 degrees or less. The flap system is interlinked with the 7 sections of leading edge slat on each wing. In landing configuration, the slats are deployed to 20 degrees, with the flaps at 40 degrees deflection. On each side of the aircraft's nose are controllable foreplanes canted down at 30 degrees. These serve the structural mode control system. The SMCS employs accelerometers to detect gusts and turbulence at low level. Control inputs are sent to the vanes and to the lower rudder section to counteract the gusts. This reduces airframe fatigue and improves crew comfort. Rockwell built 100 B-1Bs for the US Air Force, the first of which was delivered to an operational Strategic Air Command unit on the 29th of June 1985. This was the 96th Bomb Wing at Dyess Air Force Base in Texas. The second unit was the 28th Bomb Wing at Ellsworth Air Force Base in South Dakota. 3 more active duty wings received the bone: the 319th Bomb Wing at Grand Forks, North Dakota, the 366th Wing at Mountain Home in Idaho, and the 384th Bomb Wing at McConnell Air Force Base in Kansas. A rationalization of the fleet saw B-1s assigned to 2 Air National Guard units, one in Kansas and the other in Georgia. In 1993, the 96th Bomb Wing renumbered as the 7th Bomb Wing. Following on from the initial trials when the type was entering service, at least one B-1B has been assigned to the test fleet at Edwards Air Force Base, tasked with undertaking trials of new equipment and new weapons destined for the frontline force. To save money, part of the fleet was mothballed from 2002, and a number of units were deactivated. Today, the B-1 fleet flies only with the 7th and 28th Bomb Wings, numbering 67 aircraft. The B-1 was overlooked in 1991 during Operation Desert Storm, primarily because it then had only limited conventional capabilities. It was not until the 17th of December 1998 that it made its combat debut. During the short Desert Fox campaign against Iraqi air defense sites, B-1s flew 6 missions from Oman, dropping Mark 82 bombs. On the 1st of April 1999, B-1s began flying missions in support of Operation Allied Force over Serbia, eventually completing over 100 sorties, again only dropping Mark 82s. By the time that the US attacked Afghanistan in 2001, the B-1s were fully capable of dropping GPS-guided JDAM bombs, and the type was used extensively. 8 were deployed with the 28th Air Expeditionary Wing to Diego Garcia in the Indian Ocean. After the short strategic air campaign against fixed targets, B-1s began flying on-call close support missions. GBU-31s were the primary weapon, although a few Mark 82 bombs and M129 leaflet dispensers were also delivered. During the March 2003 invasion of Iraq, the B-1 established itself as the principal vehicle of the US Air Force's shock and awe campaign, dropping huge numbers of 2,000-pound JDAMs. Eleven B-1s were deployed to the 405th Air Expeditionary Wing at Tamrait in Oman, accounting for a large proportion of the 5,000 GBU-31s dropped during the campaign. For much of the conflict and for a long time after, a JDAM-armed B-1 was kept on airborne alert over Iraq, available to drop weapons or provide a low-level pass as a show of force. Its in-flight targeting capability allowed it to respond rapidly to a developing situation and provide timely air cover. Even while this effort was being maintained over Iraq, the deployed B-1s were also flying similar missions over Afghanistan. As the long-awaited successor to the B-52, the B-1 had just one mission when it entered limited service in 1985, the penetration of Soviet airspace with nuclear weapons. Although its defensive system was a long way from operating anywhere near to specification, it was still far more survivable than the venerable B-52, thanks to its low-level speed and agility. From the mid-1960s, the nuclear mission had gone low-level. Although the endgame remained the same, delivering free-fall weapons in a low-level lay-down attack, by the 1980s the difficulty of getting to the target area in the first place had increased dramatically. A proliferation of fixed and mobile SAMs in layered defenses, combined with a new generation of capable Soviet fighters, made the task of reaching the target virtually suicidal for the B-52. The B-1, with its incredible performance, might just make it through. By the time the B-1 entered service, the days of airborne alert were long gone. Instead, aircraft stood at readiness, fully armed and fully fueled. The standard load consisted of free-fall nuclear bombs, either the B-83 or the B-61 seen here. They were carried internally on rotary launchers. If the scramble alert was sounded, the four-man crew raced to their allotted aircraft and got going as quickly as possible. A feature was a switch on the nose wheel leg that, when activated, initiated the engine start process and began aligning the navigation system. Within a couple of minutes, the B-1 was taxiing for the runway. Once airborne, the aircraft climbed to altitude for a high-speed cruise. Tankers were scrambled so that the bomber could refuel en route. As it neared denied airspace, the bomber descended to low level. To penetrate into Soviet airspace through the heavy defenses, the aircraft kept as low as possible to stay under the radar and flew a carefully plotted course that routed it around the most dangerous defenses. The B-1 maintained low level throughout its ingress, attack and egress, so the aircraft was designed to spend long periods in the bumpy conditions experienced near the ground. To alleviate crew fatigue, an automatic terrain-following system flew the aircraft. The TF system could be set to follow a constant above-ground altitude of between 200 and 2,000 feet. The radar scanned out to about 10 miles in front of the aircraft, building a picture of the upcoming terrain. The TF avionics control unit drew an imaginary line parallel to the terrain, but set at the desired clearance height. It then commanded the autopilot to control the aircraft along the imaginary line. The system may have taken the aircraft around obstacles as well as over them. If any part of the TF system failed, an automatic 2.4G pull-up was commanded. During the attack run, terrain following was rapidly interleaved with ground mapping. This being made possible thanks to the electronic scanning of the radar antenna. previous terrain-following systems required an antenna that was separate from that of the main radar. On the run-in to the target, the offensive systems officer used the radar to get accurate positional updates by using offsets against recognizable features of known coordinates and by high-resolution patch maps. The updated information allowed the weapon system to compute the correct flight path, with steering cues presented to the pilot in the cockpit display. The system also computed the ideal weapon release point, and weapons were released automatically once the crew had entered the correct consent inputs. Although the B-61 and B-83 had a number of delivery modes, the main attack profile was a lay-down attack with a chute retarding the bomb. Egress was also made at low level and high speed, the latter being the main defense against interception by fighters. Of course, the B-1B also had a sophisticated defensive system that, assuming it worked as advertised, could jam or defeat most Soviet defensive systems. At the end of the Cold War, the B-1B was relieved of its nuclear mission. The US Air Force argued that its cruise missile-carrying B-52s and small force of highly survivable B-2s could handle any future scenario. But with its nuclear arsenal taken away, the B-1B had only the Mark 82 freefall bomb as a weapon. Thanks to the CMUP program, that has changed, and the B-1's mission is vastly different to what it once was. Today, the B-1 is the main muscle behind the precision weapon air campaign as employed against Iraq and Afghanistan. It is able to carry up to 24 GBU-31 JDAMs, and they can be independently targeted. During the first days of an air campaign, this allows the B-1 to strike out several strategic infrastructure targets in one mission. In Afghanistan, such targets were few, and the supply dried up quickly. The B-1 then began operating in a close support role, using its newly installed smart systems to the full. Rather than being assigned set targets, the B-1s operated in kill boxes. Each aircraft maintained a patrol in its assigned area and awaited the call to action. If a target presented itself, or if friendly troops came under fire, the B-1 could rapidly respond. Target coordinates were passed to the bomber, which then often used a synthetic aperture radar patch map to validate and refine the coordinates. The position was then fed into the weapon system and communicated to the JDAM bomb before release. As well as this hugely important ability to retarget weapons in flight, the B-1 can also carry 3 different types of weapon simultaneously to provide different weapon effects. For instance, it can carry JDAMs for precision attacks, tactical munitions dispensers for cluster effects, and Mark 82s for a carpet effect. When the B-52 entered service in the early 1950s, it was expected to be replaced by a new bomber sometime in the following decade. Of the many programs, the only one to make it to flying stage was the mighty North American XB-70 Valkyrie, a high-altitude Mach 3 bomber that flew in 1964. The advent of high-altitude surface-to-air missiles rendered the XB-70 obsolete even before its first flight. Low level was the only way to go, so the search for a bomber followed a new path. North American Rockwell, later just Rockwell, had schemed a swing-wing bomber in response to the Advanced Manned Strategic Aircraft requirement. Variable geometry allowed the aircraft to lift a huge load over a long distance, yet fly fast and low to penetrate air defenses. A request for proposal for the AMSA was issued in April 1969, and in June 1970, the US Air Force announced that its new bomber would be the North American Rockwell B-1. 3 prototypes were ordered, with a 4th added later. Requirements for the B-1A bomber stood at 240. Construction of the prototypes got underway at Air Force Plant 42 at Palmdale in California. The first aircraft was rolled out on the 26th of October 1974, already some months behind schedule. It first flew from Palmdale on the 23rd of December, landing at nearby Edwards Air Force Base, where the bulk of the testing was to be accomplished. The B-1A was designed for Mach 2 flight at high altitude and had fully variable intakes to achieve that performance. Originally, it was intended to be supersonic at low level, but that requirement was lowered to about Mach 0.85. Flight trials with the three B-1As went generally well, but the costs of production aircraft had escalated enormously. By the time President Carter was sworn into office in January 1977, the B-1 program was a prime candidate for cancellation. The coup de grace came on the 30th of June, the last day of the fiscal year. Although the B-1A was dead as a production program, development work was allowed to continue. The fourth prototype joined the test fleet in February 1979, differing from the others by having ejection seats in place of a crew escape capsule. In November 1979, while the first steps were being taken on what would eventually become the B-2, the Pentagon began looking again at a new bomber program, mainly as a carrier for air-launched cruise missiles. For the Pentagon's Long-Range Combat Aircraft, or LRCA requirement, Rockwell proposed a minimum change derivative of the B-1A. The structure was strengthened to cater for greater weights. The overwing fairings that allowed the outer wings to sweep were greatly improved, and the intakes were simplified. The latter change reduced dash speeds from Mach 2.2 to Mach 1.25, but produced big savings in weight and cost. Less noticeable, but hugely important, were the detailed shape changes and application of radar-absorbent material. Although not a true stealth aircraft, the B-1B had a frontal radar cross-section around 1/10 of that of the B-1A and around 1% of that of the B-52. Thus was born the B-1B. On the 1st of June 1981, the Reagan government announced that the B-1B was the winner of the LRCA competition and that 100 bombers would be procured. In January 1982, a contract was issued for the final design and to modify the second and fourth B-1A prototypes to assist B-1B development. The B model had around 85% airframe commonality with the A. The centerpiece of the structure was a huge transverse carry-through structure built of titanium alloy, at the ends of which were the attachments for the outer wing panels. The central fuselage body is built up of 5 sections that hold the bulk of the fuel, the weapons, and the undercarriage. They are blended into the inner wing bodies, producing considerable lift at high angles of attack. The engines nestled in pairs under the rear of the inner wing bodies. The forward fuselage section housed the 4-man cockpit and most of the nav attack avionics. As well as mounting the tail surfaces, the rear fuselage section carried more fuel and housed most of the defensive avionics racks. The outer wing panels carried fuel and retracted into neat slots with inflatable seals. There was no prototype as such for the B-1B, the first production aircraft flying from Palmdale on the 18th of October 1984. A comprehensive test campaign involved numerous aircraft and covered all aspects of the B-1B's operation, especially nuclear delivery. Initial operating capability was achieved in October 1986. Trials revealed some range payload shortfalls. Flight control system software was rewritten to allow the B-1B to approach closer to its limits in full safety, in turn improving performance figures. The final software iteration raised low-level maximum weight to 422,000 pounds from the original figure of 312,000. In 1990, the B-1B was officially named the Lancer, although it is universally referred to as the Bone. From the start, the B-1B had a nuclear role, but with the end of the Cold War, that mission evaporated as the US Air Force specified the B-52 and B-2 as its nuclear platforms. From 1993, the B-1 force entered a major upgrade known as the Conventional Munitions Upgrade Program, or CMUP. This was achieved in 4 steps. The baseline aircraft with very limited conventional capability were termed Block A machines. The first upgrade, which improved synthetic aperture radar capability, was termed Block B. Block C added the ability to carry cluster munitions and entered service in 1996, the year in which Rockwell became part of Boeing. Block D was a far more important program, as it added a mil-standard 1760 weapons interface that allowed the carriage of JDAM GPS-guided weapons. ALE-50 towed radar decoys were also added for enhanced survivability. The final upgrade, Block E, enhanced the weapon system so that different weapon types could be carried simultaneously. New weapon options were the wind-corrected munitions dispenser, JSAR, and JASM. The Block F defensive systems upgrade has been put on hold, but other development is continuing, such as the integration of the Sniper XR targeting pod.
アメリカが輸出を主目的に開発した双発の小型軽量戦闘機 F5。3代目タイガーシャークは過去の成功を受け継げませんでしたが、 F5 は多くの国でまだ主力機として使われています。次号では3代にわたったこの戦闘機ファミリーの全貌をお届けします。次号もぜひお買い求めください。